Welcome everyone. Welcome to this lesson. Today we're going to be talking about the neuromuscular junction. As you can see here, the top part here is your neuron. Okay, this is your axon coming down. You have the axon terminal right here, and then you have a gap. Okay, you have a space. Space is called a synaptic cleft. Okay, this is your neuron that coming down. The word neuromuscular junction. Neuro is your neuron. Muscular is your muscle fiber, and it's a junction between your neuron and your muscle fiber. So when you tell your finger to move, when you actually tell your finger to move, you send the information down here, and somehow you tell your muscle down here to move. So the top part here, okay, top part here um, is your neuron. The bottom part here is your muscle. Okay, we're going to talk about both of them. Okay, in this video, we're going to talk about your neuron. How does your neuron works, and how does your muscle actually works. Okay, so without further ado, let's get to it. Okay, um, so first thing you see here, you have the axon. Okay, you have the axon that's coming down, and here at the end is called the axon terminal. Okay, axon terminal is at the end. Okay, um, so at the end here, okay, when you actually tell your brain, like when your brain tells your muscle to move, okay, when your brain tells your muscle to move, you send this AP, which is the action potential. You send this electrical signal or the action potential, which we'll talk more about that in the next chapter, in the neural chapter, how this actually works. But just know for now that you're sending electrical information down to your axon terminal, okay? Sending this action potential electrical stimulation down. This is pretty much similar. Just think of it, you have that electricity kind of going down. Think of action potential is pretty much the voltage or current of the electricity, just going from this point down to this point. Okay, when they actually hit, okay, when they hit the down, so you have these action potential, the electricity coming down. When it hit the axon terminal, it tells this guy right here, okay, the calcium voltage gate channel. So calcium is Ca. Vg stand for voltage gate. Okay, voltage gate. What does that mean? That means this channel, this gate, is only respond to the voltage or respond to electricity. Okay, it respond to electricity. When you have that electricity hits this gate, okay, guess who's going to be coming in? Calcium is going to be coming into this channel. Calcium start to rush in. So just imagine, just think of, I don't have actually calcium, so think of these guys. So think of these as calcium. Calcium would be just coming in, okay? Think of calcium would be just rushing into this gate, okay? When calcium rushes in, okay, when calcium rushes in, the vesicles start to move down, okay? Right here, you could see the vesicle. Vesicle basically is just a bag, okay? What's inside the bag? We actually have neurotransmitter. This is one of them. This is called acetylcholine, okay? Acetylcholine, abbreviation is ACH. You can see right here, ACH, acetylcholine. Okay, so in this vesicle is just a bag. You actually have a whole bunch of acetylcholine resting inside your vesicle. Okay, resting inside your vesicle. As the calcium comes in, you have calcium open, this gate open because of that electrical impulse, that action potential electrical impulse open up this gate. So calcium leaks in, comes into this axon terminal. As it comes in, it moves the vesicles down. Okay, move these vesicles downward. Okay. Think of this vesicle as kind of like ejection seat. Okay, ejection seat. If you watch Top Gun, you actually will see this ejection seat coming down. As it comes out here, these acetylcholine will be released into the synaptic cleft. Okay, these acetylcholine will be released into that synaptic cleft. Okay, so keep that in mind. To reset, okay, eventually the electrical signal stop. Okay, to reset, we use this calcium pump. Okay, calcium pump. This is using ATP, using energy to pump out these calcium back on the outside, kind of resetting everything. Okay, kind of resetting everything. So we pump this using ATP, converting ATP up to ADP, and then we pump out these calcium. Calcium goes back out. Okay, so keep that in mind. So that's what happened right here at the axon portion of the NMJ. So first you have the electrical potential, which is action potential coming down. These two action potential comes down from your brain down to the axon terminals. When it comes down, it opens up the calcium gate. Calcium, second thing that happened is opening up the voltage calcium gate. Then the third thing, calcium comes in. When calcium comes in, these vesicles that hold acetylcholine moves down, and then you release those acetylcholine into the the synaptic cleft, synaptic space. Okay, to reset, you actually use ATP, using energy ATP to pump the calcium out, pump the calcium back up. Okay, to reset back to original stage. Okay, what happened now? What happened to the acetylcholine in the neuromuscular junction? Let's look at that. Okay, and we'll come back to that. We'll come back to this again when um, come back to this again at the end. What happened when we reset everything back to where we started? As you notice here, let me move the camera down a little bit. Okay, good. As you notice here, okay, this is what it looks like in terms of resetting. Okay, this is at the beginning stage. This is what we have at the beginning stage. Okay, we'll have this at the beginning stage right here. You have the cholinergic receptors. Okay, and then you have sodium kind of floating around in this synaptic space as well. You have the calcium. So think of these as calcium. Okay, we could use this as well for calcium to come in. Okay, so calcium actually stay inside the sarcoplasmic reticulum, the SR. This is home to the calcium. This is where they store. If I ask you a question on the exam, where does calcium actually store? You would say sarcoplasmic reticulum. Okay, sarcoplasmic reticulum. And on the bottom here, you have the actin and myosin. Okay, actin and myosin. As you can see here, always remember actin. Actin is the one that moves. Okay, actin is the one that moves. Myosin is the one that stays still. Okay, myosin is the one that stays still. So actin is the one that moves around. Okay, myosin filament. So think of this. You have the myosin here in the middle here, and then you have the actin right here. Okay, actin is the one that actually moves around. Okay, it will contract, become like this, and then will expand. So actin actually moves. Myosin does not move. Okay, myosin have these little heads. Okay, think of these myosin. So actin, the easy way to remember actin, since it's moved because it's acting, it's moving. So when you act, you actually have to move all the time. When you act, you have to move. So actin is the one that will move in when your muscle contracts. And when it relaxes, it moves out. Okay, so actin always move. Myosin stays still, doesn't move. Myosin have these little heads. Okay, on the actin, it actually have something that blocks it. Okay, you have the tropomyosin, which is long thing right here, and the yellow blob here is the troponin. Troponin is the one that block the binding site. So again, if you remember my my lecture, actin and myosin are lover. They two lovers. They want to be with one another. However, you have this troponin blocking them from being with one another. They cannot be with one another because these troponin block them. They cannot join in happy ending, so they cannot be with one another. So they're blocking troponin and actin to see one another. Okay, so this is the original setup. This is what it looks like. Okay, when your muscle is actually relaxed. Okay, so when the vesicle released, when the vesicle knock down the skeleton, when the vesicle actually releases the acetylcholine, okay, when they release acetylcholine, acetylcholine then goes to this cholinergic receptor right here, okay, going to these cholinergic receptor. And what happened once it goes to the cholinergic receptor, okay, then it opens up the gate. It opens up the sodium gate, okay. The sodium will start to rush in, okay. Sodium start to rush in. So think of this cholinergic receptor is a gate, it's a sodium channel gate, okay, sodium channel gate. So when this opens up, the sodium comes in. When the sodium comes in to your muscle cell, it becomes an electrical impulse, okay. Think of it as become an action potential or electrical impulse that's sending down the T tubules. This is right here, T tubule, which is transverse tubules, okay, transverse tubule, okay. So think of it as sending that electrical impulse or action potentials, thinking they're sending that voltage, electricity going down that T tubules. When this comes down, it opens up the gate for calcium. So letting the calcium let loose, okay, letting the calcium loose. Who lets the calcium out? Okay, I will ask you that question as well on the exam. Who lets the calcium out? And the answer is the sodium, okay? Because of acetylcholine opens up sodium to come in. Sodium coming in, you have this voltage, electric action potential, that voltage that go into your transverse tubule, T tubule, it opens up, letting the calcium out. What does the calcium do? Calcium bind with troponin, okay? Calcium bind with troponin. When calcium binds with troponin, it opens up, okay, the binding site, okay, like this. So when calcium binds with that troponin, the binding site becomes open. So now these two lovebirds can actually be with one another. Okay, these two lovers can be with one another because now no one is blocking them to be with one another. Okay, so that's what happened. Okay, and that's when these we talked about it before. When these two lovers comes together, you have the action potential. You actually have binding. You're using the ATP. Okay, you're using the power stroke. Okay, the power stroke happen is when you hydrolyze, hydrolysis of um, the ATP. You actually move things around, and you need another ATP to let go, and then bind onto it again, and then keeps coming closer and closer and closer. Okay, and that's how your muscle actually contraction happen because of these calcium binding to the uh, troponin, opening up the for actin for the actin and myosin. So actin here, myosin here, to actually bind with one another, and then causing the actin to move, contracts, coming close to one another. Okay. Now, even though that's done, that's how your muscle actually, every time you move your muscle, that's how you contract your muscle. The biggest thing to remember is, how are we going to clean this up? How are we going to go back to normal? Okay. The way to go back to normal, a couple of steps to remember. One, okay, number one is we're going to put calcium, okay, back. Okay, we're going to put calcium back where? We're going to store them back in the sarcoplasmic reticulum. We're going to put your calcium back into that sarcoplasmic reticulum, back where they belong. Okay. The second thing is, again, you need to close down the gate. Okay, closing down this, stop this action potential. So close the gate of sodium, and then pump the sodium back out by using ATP. Okay, using ATP to pump the sodium back out to these. Okay, pumping sodium back out into the synaptic spaces. Okay, that's number two. And the last thing that you do is also we clean up. We use ACHE, acetylcholinesterase. Okay, this is an enzyme that get rid of acetylcholine. Okay, enzyme that get rid of acetylcholine. So this guy come in and then eat up or breaking down all of these acetylcholine. So when it breaks down, the gates close. Okay, all the gates close, and then we use the sodium potassium pump to pump sodium back out into the synaptic cleft. Okay, so stop this whole motion, and then things go back to where it was. Whereas again, um, troponin is blocking uh, troponin is blocking actin and myosin to be with one another. Okay? And that's when your muscles start to go back to relaxed state, not using. And that's the steps of the neuromuscular junction. As acetylcholines clean up, the vesicle again go back, and your body will reuse, will actually remake the acetylcholine. Your body will start putting new acetylcholine back in it again. Okay, to restart this whole process every time when you actually trying to move your muscle, you will have all of these reserve waiting for you. I hope this is helpful. I hope kind of clear up and help you understand the neuromuscular junction process a little bit better. If you have any question, please let me know. You could rewind this video to different sections if to kind of help you understand a little bit better. Okay. Thank you so much for watching, and I'll see you in the next video.